Hello friends, welcome back to my channel. This is a continuation of my discussion on networking techniques. Till now I have discussed activity diagrams. I have discussed two types: activity on arrow, that is AOA diagram, and activity on node, that is AON diagram. I have discussed these two diagrams. Then I have discussed terminologies that is used in networking techniques, where I have explained various terms that are used in these networking techniques. Networking techniques, these are used for scheduling project activities in project management. Then I have also discussed how to draw a network diagram, that is how to draw an activity on arrow diagram if you have a list of project activities. And then I have started my discussion on critical path method, the method that is used to identify the critical path for completing project activities. And today I will continue my discussion on critical path method. And here in this particular video I'll be discussing two different terms. One is slack and the other term is float. We will be understanding three different types of floats, and at the end of today's discussion you will be able to use the values of slack and floats to identify the critical path. So that will end our discussion on critical path method, and in coming days I'll be posting a video where I will solve one numerical where you learn how to identify the critical path method. I will give links to all my previous videos on networking techniques in the description section, so that those of you who have not yet seen those videos, they can watch those videos. They will understand the concepts. And if you have any doubts, you please let me know. You can comment in the comment section. And most importantly, if you have not subscribed to my channel yet, you please do subscribe to it and tell your friends to subscribe to my channel. Okay, so let us start the discussion. So the discussion is on networking techniques, and I'll be talking about critical path method. So as I said, we are going to understand different terms, two different terms. One is slack. So we are going to denote that by tau. And how it is defined? It is simply defined as a difference between latest and earliest event times. So latest and earliest event times, this I have already discussed in my previous videos. You please watch those videos. So simply a difference between the latest and earliest event times, that is nothing but slack, and we denote it by tau. We denote that by tau. So mathematically you can write a simple equation for that. Tau is equal to LE minus EE, where LE represents latest event time and EE represents earliest event time. The other way of understanding slack is nothing but maximum allowable delay in the event without disturbing the project schedule. Maximum allowable delay in the event without disturbing the schedule is nothing but slack. And how to calculate it? You can calculate it by using this equation. Tau is equal to LE minus EE, that is latest event time minus earliest event time. Then the other term that we will be understanding today is float. How to understand this? Float is nothing but a difference between the available time and the activity duration. Difference between time available for completing an activity and the actual activity duration. Available time, difference between available time and the activity duration. So this is nothing but float. And we are going to understand three types of floats. Which are these three types? First is total float, second is free float, and third one is independent float. So we will understand each of this type, and when you understand these three floats, you'll be able to calculate them. Okay, so let us move ahead. First in the list was total float. Let us denote it as TF. Total float, let us understand what is a total float for an activity. So what is this? A difference between the maximum available time for an activity and its duration. So maximum available time minus the activity duration, that is nothing but total float for that activity. A difference between the maximum available time for an activity and its duration. This is total float. We are going to denote it as TF. So total float for an activity is a difference between the maximum available time for performing an activity and its actual duration. Okay, the maximum available time for performing an activity. How to get that? Maximum available time is nothing but the difference between latest event time for the head event and earliest event time for the tail event. So if you take difference between these two, which two? Latest event time for the head event and earliest event time for the tail event. So difference between these two is nothing but the maximum available time, that is the maximum time that is available for completing an activity. So let us understand this with an example. So for example, this is event 1. It will be having earliest event time, let it be EE1. It will be having latest event time, let it be LE1. And uh, then you have the activity. So event 1 is the start event for activity A. Activity A will be proceeding for duration dA, and activity A will complete at event 2. Again for event 2, you have earliest event time, that is EE2, and latest event time, that is LE2. So for this example, for this simple example, event 1 is the tail event for activity A, and event 2 is head event for activity A. Once you know what is a tail event and, what is the head event, now you can easily write equation for maximum available time, or you can easily get the maximum available time. So maximum available time is, what is the definition? Difference between latest event time for head event. So in this case, event 2 is the head event, and for event 2, latest event time is LE2, and difference between this and earliest event time for tail event. So event 1 is the tail event, and for this tail event, earliest event time is EE1. So for this simple example, the maximum available time, I'm denoting that as Tmax. The maximum available time will be equal to latest event time for head event, that is LE2, minus earliest event time for tail event, that is EE1. Okay, so once you know how to get maximum available time, then you can write equation for total float. So total float will be maximum available time minus activity duration. So TF is Tmax minus dA. You already have equation for Tmax over here. So Tmax is LE2 minus EE1 minus dA. And if you rearrange it in a different way, you can write it like this: total float is equal to LE2 minus dA minus EE1. I have just changed the places of the terms. Now why I'm doing this? Because I know LE2 minus dA, that is latest event time for head event minus activity duration, is nothing but latest start time for that activity. And for this example, LE2 minus DA will give you latest start time for activity A. And you also know earliest event time for the tail event. Earliest event time for the tail event, that is event 1, is nothing but the earliest start time for that activity. Okay. So having understood how to use these two terms, which two terms, latest start time for the activity and earliest start time for the activity. So what I am going to do in this equation, in the equation for TF, LE2 minus DA will be replaced with LSA, that is latest start time for activity A, and EE1, it will be replaced with earliest start time for activity A. So if the replacement is done, you have this equation. Total float is equal to latest start time for the activity minus earliest start time for the activity. In this example, we are talking about activity A. So total float for activity A will be difference between latest start time for activity A and earliest start time for activity A. Okay. So this is the final equation which you can use for calculating total float for any activity. Okay. So from this equation, what I can say, thus the total float for an activity is the difference between its latest start time and earliest start time. Simple other way of understanding total float. So total float for an activity is nothing but difference between its earliest start time and latest start time. Okay. So on this slide, on this particular slide, we have understood what is total float. What is total float for an activity? Let us move ahead. Next is, after understanding total float, next thing that we are going to understand is free float, and we are going to denote it as FF. So free float for an activity. So what is this? It is a difference between the earliest start time for the activity, earliest start time for the successor activity, and earliest end time for the current activity. So when you are defining free float of for an activity, let that activity will be the current activity. Then what is the definition? Free float is a difference between earliest start time for the successor activity, successor to the activity for which we are defining free float. Okay. So a difference between the earliest start time for the successor activity and earliest end time for the current activity. Earliest start time of activity for the successor activity and earliest end time for the activity, which activity for current activity. Okay. So once again, you try to understand free float is difference between earliest start time for the successor activity and earliest end time for the present activity or current activity. Okay. So for example, let us understand this with the help of an example. So you have event 1, again same simple example, because that will help you in understanding the concept. So event 1, earliest event time is EE1, latest event time is LE1. You have activity A that is going to proceed for duration DA. It will complete at event 2, which has earliest event time EE1, latest event time LE2, EE2 and LE2. Okay. Then event 2 acts as start event for activity B, which is going to proceed for duration DB, and it is going to get completed at event 3, for which you have earliest event time EE3 and latest event time LE3. Okay. So you have two activities A and B. So if you are talking about activity A, then activity B will be the successor activity for that. Are you understanding it? So here in this case, as I said earlier, activity B is a successor to A, and therefore with this definition, what is the definition? Difference between earliest start time for successor activity. In this case, successor activity is B, so we are taking into account earliest start time for activity B minus earliest end time for present activity, or for the activity for which we are finding free float. So free float will be earliest start time for activity B minus earliest end time of activity A for this particular example. Okay. So let us again simplify this. So what is done in this next step? Therefore, free float is equal to earliest start time for an activity. For over here it is for activity B. Earliest start time for activity B. It is nothing but earliest event time for the tail event. For activity B, tail event is 2, and earliest event time for that event, for the tail event, is nothing but earliest start time for that activity. So earliest start time for activity A, for activity B, is nothing but earliest event time for event 2. What is the reason for that? Because event 2 is the tail event. So earliest time for tail event of an activity is its earliest start time, and latest event time for head event of an activity, that is the other thing, that is LE2. In this case, for event 2, the latest event time is LE2. Are you understanding it? So since earliest event time for the tail event of an activity is its earliest start time, therefore, you have earliest start time for activity B is equal to EE2. Okay, and earliest end time for an activity is earliest event time for the tail event for plus activity duration. Okay, so what is the case? We have modified this equation. We have written what is earliest start time for activity B, and we have also written what is earliest end time for activity A. So that is earliest event time for the tail event plus activity duration. So if you rearrange this equation, how is it rearranged? So free float will be equal to EE2 minus EE1 minus DA. So we are multiplying this negative sign into the bracket. So this will be free float is equal to EE2 minus EE1 minus DA, and that is the final equation for calculating free float. So if you know EE2, if you know EE1, and if you know the activity duration, you can get free float for that activity. So in words, how can you understand? Earliest event time for free float for an activity is equal to earliest event time for the head event minus earliest event time for the tail event minus the activity duration. So in this example, for activity A, 1 is the tail event, 2 is the head event. So likewise, you have earliest event time for the head event minus earliest event time for the tail event minus activity duration. This will give you free float. Okay, so I hope this is clear to you. If you have any doubt or if you have not understood, you please write it in the comment section. I'll just help you on that matter. Okay, so that ends our discussion on free float. Now we know how to calculate total float. Now we know how to calculate free float. Now let us understand the third type of float, that is independent float. Independent float for an activity. So what is this? This is the time by which the starting or finishing of an activity can be delayed without affecting total float of its preceding and succeeding activities. So what is this? How to understand independent float? We are going to denote independent float by IF. So independent float for an activity is nothing but the time by which starting or finishing of that activity can be delayed without affecting the total float of the preceding as well as the succeeding activities. Okay, so without affecting total float of preceding and succeeding activities, the time by which you can delay the starting or finishing of an activity, that time is nothing but independent float, and we are going to denote that by IF. Okay, so the time by which the starting or finishing of an activity can be delayed without affecting total float of its preceding and succeeding activities. So mathematically, how it is given? So it is independent float, that is IF is equal to total float minus slack for head event minus slack for tail event. IF is equal to total float minus tau for head event. Tau, we have just understood tau is nothing but slack for head event minus slack for tail event. So we are going to understand this with the help of an example. So I'll discuss that example so that the concept is clear to you. Okay. So what is the example? Let us understand. So with continuation from the previous slide, I am again writing equation for independent float. I have just told what is the equation. The equation is independent float is equal to total float minus slack for head event minus slack for tail event. For example, again let us consider event 1, which has earliest event time as EE1, latest event time as LE1. Then you have activity A, whose duration is DA, where the activity is completing at event 2, which has earliest event time as EE2 and latest event time as LE2. Okay, so this is tail event, this is head event. Okay, so now as per definition for independent float, it will be total float. Total float for this activity, for this example, total float is difference between latest start time and earliest start time. That is what I have used over here. So independent float is equal to latest start time for activity A minus earliest start time for activity A minus slack for head event. Head event is event 2, and for that slack is LE2 minus EE2 minus slack for tail event. Tail event is 1 and slack for event 1 is LE1 minus EE1. Okay. So what have we done in this step? We have simply written equation for total float. We have simply written equation for slack for head event and then slack for tail event. Okay, let us simplify it further. So how? I have just simplified in the next step. So independent float is equal to latest start time for activity A minus earliest start time for activity A minus, I have multiplied with negative sign in the bracket. Same thing over here. So this is minus LE2 plus EE2 minus LE1 plus EE1. Okay. In the next step, there is little bit arrangement. So you can see what happens. You have latest start time for activity A, and then you have earliest event time E1. Then you have again we have just simplified it. How this is simplified, let us understand. So here you have latest start time for activity E. Okay, so in place of that we have we have written equation for latest start time. Latest start time for activity A will be latest event time for head event, that is LE2, minus duration of that activity. So that will give us latest start time for activity A. Similarly, earliest start time for activity A is nothing but earliest event time for tail event. So here tail event is 1. So accordingly you have EE1. Okay. The rest of the terms are kept as it is, minus LE2 plus EE2 minus LE1 plus EE1. And finally, we are going to simplify it further. So simplification, what will happen? This EE1 gets cancelled here, or here it is minus EE1, or it is plus EE1, so both get cancelled. Similarly, the other things, that is LE2 minus LE2, that also gets cancelled. So what are we left with? Independent float will be EE2 minus LE1 minus DA. So that is the final equation for calculating independent float. So independent float for an activity is earliest event time for the head event minus latest event time for the tail event minus duration of that activity. Okay. So in this, okay, so now we know what is slack for an event, what are floats for an activity. Three different types of floats. You have total float, free float, and then independent float. Now let us learn how to use this, how to use values of slack and then different types of floats to identify activities on a critical path. So in short, we are going to understand how to identify activities on a critical path. Okay. So for those activities for which head and tail events have same earliest and latest event times. Okay, that is earliest event time is equal to latest event time. If this is true for head and tail events for an activity, then that activity lies on a critical path. All those activities whose head and tail events have equal earliest and latest event times, then those activities will fall on a critical path. Okay, so for these events, slack will be 0, that is tau is equal to 0. The other thing is all those activities for which earliest and latest start times are equal, all those activities will also lie on the critical path. Earliest and latest start times are equal. That is, earliest start time for an activity is equal to latest start time for an activity. If this is true for any activity, that activity will lie on the critical path. Then for all those activities whose floats are 0, all floats, total float is 0, free float is 0, and independent float is 0, all those activities will also lie on a critical path. Let us understand this with the help of an example. For example, you have event 1, E1, L1, earliest and latest event time, activity A, duration DA, event 2, earliest event time EE2, latest event time LE2. Okay. So this is tail event, this is head event. So for tail event, if this is true, that is earliest event time is equal to latest event time. And for head event, again, if this is true, earliest event time is equal to latest event time. That is slack for tail event is 0, slack for head event is 0. Then activity connecting these two events will lie on the critical path. Similarly, if activity A has earliest start time same as that of latest start time, then that activity will lie on the critical path. Okay. So in this way, and finally you can conclude that activity A is on the critical path. Similarly, all three floats for activity A, if all these three floats are equal to 0, then that activity will also lie on the critical path. That is, you conclude that activity A lies on the critical path. Okay, so with this I end my discussion for today. So here I have told you about three concepts: slack of event, and then three different types of floats for an activity. And then I have also told you which activities will lie on the critical path, how to use values of slack and three different types of floats to check whether the activity is lying on the critical path or not. Okay, so I hope you have understood what I have discussed today. If you have any doubt, you please mention that in the comment section. Do subscribe to my channel, hit the bell icon, and if you have really liked my video, you hit the like button. You also hit the bell icon so that you will get notified as soon as I upload a new video. For time, thank you for being with me. Hope to see you very soon.